What's up? So I have a problem here. Got the pen working, and I wrote a little something. Side graffiti. Problem is that I'm working with something problem of recursive architecture. Working with a problem of recursive architecture, and Don Knuth talked about this in his discrete mathematics textbook. That you have a base. It's recursive architecture. So this is an actual architectural pylon or something that you have one smaller, one smaller, one smaller, one smaller until you end up with one unit. So there's a base for this recursive pylon, right? And that's called the base size in units. The next one is I call it the particular size element. So you have the base size element. The particular size element is, you almost come up with it. Particular. Okay? Then there's the next one. Talking about this in the abstract, it's called the particular continuation. Nope. It's called the derived continuation. And then it repeats that derived continuation until you hit the piece of 1 unit in size. 1 unit. What was the derived continuation? Kind of sort of making up words, but this is based on proof by induction. So it's recursive architecture. It's real. They're in units. That is based on the proof by induction. So we want to work in the abstract. I need a formula for a cylinder of the particular size. A formula for the cylinders. I need like a formula for cylinder for that base size. It ain't length times width times height. Let's see if I can work that out. There's a center. There's R. Radius. The radius for an oval, that's like is it an oval? No, it's a circle. It looks like an oval. It's actually a circle. Right? Is it pi r squared? Is it pi r squared equals the area? Area equals pi r squared. I'm sorry, you can't really see that. Area equals pi r squared. And you want to multiply by d is for depth. Pi r, so the base equals pi r squared d, I think. That's the way I would do it. Then this next one is particular size, just for this case. There's all kind of ways to do this. You can do this differently every single day. Like I said, this was Don Knuth, discrete mathematics. It's all different thing. Don Knuth, discrete mathematics. This particular, I want to make it the decision like changes. The decision. How do we do this? The decision on that next one changes the way you do this problem every single day. I'm gonna make it about a third less, so that there's the base. The particular, I'm gonna make it like 1/3 of the base. So there's the base by r squared d. This one's 1/3. Now there's going to be a derived continuation. Like you derive how it continues, and then prove with the proof by induction that your derivation, you prove this right here with induction, the derived continuation, until you hit 1 unit. So the first thing we do is that you want to do the base. You want to do the base first, all right? You do the base first. You're gonna have the base plus 1/3 of the base for the particular. You got to know that. It'll be pi r squared d plus 1/3 pi r squared d. So you get what? 2/3 pi r squared d. Okay, but then you do what? You start with that 2/3 pi r squared d plus the 1/3. Like it's almost like a pattern pi r squared d. You just continue. This is just continuing stuff. We haven't found that derived continuation pattern yet. So it ends up being a whole. You know what? I messed that up. It's actually going to be 3/3 plus, it's actually 4/3. So you're going to get 4/3 plus 1/3 equals 5/3 pi r squared d. And it looks like the pattern is the base is so you have the base, you have the first one base, the first one, the second one. So the pattern at step n equals n plus 1 over 3 pi r squared d, I think. That's the pattern. N plus 1 over 3 pi r squared d. So the proof, you have to, in order to really know, you have to prove that by induction. And that's where I might be messing up. Go to this page over here. I think you want to do is proof by an induction. I might get AI to help me out afterwards. I think you want to assume the base case. No, you want to say what is the base case. Wisdom. Use wisdom. We have a form pattern. I was going to stop. We have a formula pattern. N. We do have a formula pattern. N equals n plus 1 over 3 pi r squared d. Assume, you actually get to make an assumption. Assume pattern that's where I need to stop, because I forgot.